All right, so now we're going to look at polar conversion. So we want to understand how we can convert polar coordinates to rectangular coordinates and rectangular coordinates to polar coordinates. So how do we do that? Excellent question. I'm glad you asked. I'm going to show you. So how do I convert from polar to rectangular? Well, what do you think? We're going to use trig. Okay, how? Right? Well, let's think about what we know. Well, I know cosine of theta is adjacent over hypotenuse. But in terms of my picture, so if I have some polar point here, where this is r theta, I know that this is x and this is y, right? Where this is r and that's theta. So I know that this also equals x over r. So my conversion then, I can say that x equals r cosine theta. Now, it should make sense then that y equals r sine theta. Well, what about going the other direction? How do I convert from rectangular to polar? So I want you to try to think about that on your own, by yourself, on your own. Try that. Pause the video, unpause when you're ready to discuss. All right, so let's discuss. Well, basically, think about what are we doing? We're looking for relationships. So what are the relationships between x and y and r? Well, Pythagorean theorem. So I know x squared plus y squared equals r squared. And what about between theta and y and x? Well, I know tangent of theta is y over x. So this is my relationship between theta and y and x. This is my relationship between x, y, and r. Let's put this in practice. So I want you to try and convert the following to rectangular. So here I have two different coordinates in polar. Convert them to rectangular. Pause the video, unpause when you're ready to check. So for the first one here, hopefully you ended up with the point 0, 16. And how do we get that? Well, we get that because I know x equals 16 cosine of 5 pi over 2. Cosine of 5 pi over 2 is 0, so x equals 0. Y equals 16 sine 5 pi over 2. Sine of 5 pi over 2 is 1, so y equals 16. For the other coordinate, x equals negative 3 cosine negative pi halves. Cosine of negative pi halves is 0. X equals 0. Y equals negative 3 sine of negative pi halves. Sine of negative pi halves is negative 1, so y equals 3. So I get the point 0, 3. Fantastic. Moving on, let's try to go the other direction. Convert the following to polar between 0 and 2 pi. So write your answers between 0 and 2 pi. Pause the video. Unpause when you're ready to check. Okay, so here we have two different ways in which we can actually represent the first coordinate point. So we want to recognize, okay, this is in quadrant 3. I know that. So first, let's find r. Well, I know x squared plus y squared is r squared, so r is 3 root 2. And I know theta is the tangent inverse of y over x, or tangent of theta is negative 3 over negative 3, which is 1. So theta is going to be 5 pi fourths. So I can either say 3 root 2 comma 5 pi fourths, or negative 3 root 2 comma pi fourths. Either of those would be a correct representation. They are equivalent locations in polar coordinates. The next one, the answer is not as nice because we don't get a nice angle from the special angles we know on the unit circle, but we can still do the problem. So I know r squared is 5 squared plus 12 squared, so r is 13. That was nice of me. Tangent of theta is 12 over 5. Well, that's not going to be a super nice angle. So theta is just the tangent inverse of 12 over 5. Now, I do want to recognize this is in the first quadrant. So the tangent inverse of 12 over 5, which is also in the first quadrant because of the range of the tangent inverse function, this is an acceptable answer. Are there other ways we could write this? Yes. Is it worth doing that? Probably not, because we have to leave our answer in terms of tangent inverse. What if we have equations? So, yeah. All right, I want you to try this on your own. I have faith in you. You can do this. We're almost done with the year. Summer's almost here, but you are still focused. I know it. So convert the rectangular equations to polar form in terms of r and theta. Solve for r if possible. So you're not always able to do that. So try y equals 3. Try 3x plus 5y minus 2 equals 0. And try x squared plus y squared minus 8y equals 0. Pause the video. Do that. Unpause when you're ready to check. All right, so y equals 3. First, let's actually think about this. What is y equals 3? That's a horizontal line. So that's a really, really simple equation in rectangular form. What does it look like in polar form? Well, I know y is r sine theta, so I know r sine theta equals 3. So then solve for r if possible. R would be 3 over the sine of theta, or 3 cosecant theta. So a horizontal line of y equals 3 in rectangular is written as r equals 3 cosecant theta in polar. Think about that. It's kind of cool that those two things are going to give you the same exact graph. Boom. Mind blown. Let's keep going though. How about 3x plus 5y minus 2 equals 0? Well, x is r cosine theta, y is r sine theta. And again, think about, well, what's this equation? That's just another line. Now, it's not a horizontal line, but it's still just a line. So what does that look like? Well, I can factor out the r, divide by 3 cosine theta plus 5 sine theta. So r equals 2 over 3 cosine theta plus 5 sine theta. Again, that's just the equation of a line. This is what it is in polar. How about this one here? X squared plus y squared minus 8y equals 0. Well, I know x squared plus y squared is r squared. Y is r sine theta. So I get r squared minus 8r sine theta equals 0. I can factor out an r. So I get r equals 0, but I know that's actually not going to be part of my answer. And I also get r equals 8 sine theta. So this one we see, so we get r equals 0, but this is not going to be the actual equation, right? Because think about, what is this equation? Well, in rectangular, this is a circle. If you put it into standard form, you'll see that it's a circle with a radius of 4 and a center of 0, 4. So it will go through the origin, or the pole, but it's a circle, so it can't just be r equals 0, because r equals 0 is just pole. So my equation is actually r equals 8 sine theta. Now this is a good example of something that's somewhat complicated in rectangular, has a very simple equation in polar. So, think about this. These two, which are both very simple equations in rectangular, are somewhat complicated in polar, but then this one, which is somewhat complicated in rectangular, is a relatively simple equation in polar. Who knew? Try going the other direction. Theta equals 11 pi sixth, r equals secant theta, and r squared equals sine of 2 theta. So convert these polar equations into rectangular form in terms of x and y, and solve for y if it's a function. So pause the video, unpause when you're ready to check. Okay, so theta equals 11 pi sixth. What is that going to be? Well, it should make sense what this comes out to be. I can convert this because I know tangent of 11 pi 6, or tangent of theta is y over x, so tangent of 11 pi 6 is y over x. So I get negative root 3 over 3 is y over x, so y equals negative root 3 over 3x. That's a line with a slope of negative root 3 over 3, goes through the origin. That should make sense because this is just representing every point on this angle, which is a line. r equals secant theta. Well, secant is 1 over cosine of theta. So I know that r cosine of theta equals 1. But r cosine of theta is x. So x equals 1. So again, this is a super simple vertical line in rectangular form. But in polar form, it looks more complicated. R equals secant theta. It's crazy. I'm I'm amazed. And I'm the one teaching this. Next one, r squared equals sine 2 theta. Well, I don't like sine 2 theta because I don't like the double angle. But I can change it to sine theta cosine theta. Boom. Sine theta is y over r. Cosine theta is x over r. This is r squared. Now I have r squared in the denominator here. Multiply both sides by r squared and I get r to the fourth. Okay, how is that helpful? Well, so I end up with r to the fourth equals 2yx, but r squared is x squared plus y squared, so r to the fourth is x squared plus y squared squared. Don't try to solve this. This is not a function, so don't try to solve it for y or isolate the y in any way. Just leave it like that. Okay, so conclusion. The same point in polar can have multiple representations using positive or negative versions of r and positive or negative versions of theta and coterminal angles. That's why we usually have a restriction of 0 to 2 pi or negative 2 pi to 2 pi in terms of representing polar points. But there would technically be an infinite amount. Polar to rectangular, we want to know our relationship x equals r cosine theta and y equals r sine theta. Rectangular to polar, tangent of theta is y over x, and r squared equals x squared plus y squared. All of these are not new relationships. We know them all from right triangle trig. That's all we're doing here.